Now, if you watch the video I did on volumes of washers with horizontal axis of revolution, you'll notice that these are the exact same curves as that problem. And that's because really it's not about the curves, it's about the setup, right? So if you remember, if you didn't watch the video, let's catch you up here real quick. Basically what happened was we had a parabola here that had a y-intercept of 3. Then we had a line that was intersecting with the parabola, and that intersection point was 3/2, right? And we were rotating this region around a bunch of different horizontal lines, x-axis, y equals -1, y equals 8, that kind of thing. Well, now we're going to switch it up a little bit. Now we're going to start by rotating it around the y-axis, a vertical line of revolution. Immediately what that does is that forces us to have to change the functions from functions that are in terms of x to in terms of y. So that's really where the work begins. So I need to say, all right, well, if this is y equals 2x squared plus 3, what would that look like when I solve for x, right? So let's see, y minus 3 equals 2x squared, divide by 2, right? So this first one, right, x would equal the square root of y minus 3 over 2. Okay, hold on to that. Now let's go, let's draw a little bit of a line here. Let's go do the other one, right? So y equals 3x plus 3. And when I solve that for x, I'm going to wind up with x equals y minus 3 over 3. So I have this one right here. I have this one right there. Those are my two functions now in terms of y. All right, so am I ready to kind of set up the integral? Pretty much, but remember, that's not the only change. Yes, we're changing the functions, but that means we're also changing the limits of integration. So no longer are we going from 0 to 3/2. Now we're going from 3 to whatever the y coordinate is of that point right there, and we don't have that conveniently, right? So let's come on over here and find that out. Pick either function you want, right? Let's do g. And so let's go do g of 3/2, right? Let's see, 3 times 3/2 plus 3. So 9/2 plus 3. So 15 over 2. Okay, great. So that is, let's call it 7.5. Right? That is now my upper limit of integration. My lower limit, so here's 7.5, right, must be 3. Still got the pi on the outside, right? Now, when we talk about outer radius versus inner radius, again, the determining factor is how far is the function away from the axis of revolution, which one is farther. So when I look at this, right, I'm about to revolve it around the y-axis, so I can see the parabola is the one that's farther away, so that's got to go first. That's my outer radius, and that was rewritten right here. So I'm going to start with the square root of y minus 3 over 2 squared. That's my outer radius, and now my inner radius is going to be the line, so that's y minus 3 over 3 squared, and all of that, of course, is in terms of y. So there you go, a really big change in the setup, but the concept is the same. There's an outer radius, there's an inner radius, there's a pi constant on the outside, there's a lower limit of integration, an upper limit, right? So all that is very similar. All right, now where do we go from here? Well, just like in the disk method video, right, we're going to revolve this around some other lines, and that changes things. That means the radius function is going to have to now take off whatever that line is. So let's go in here, and now let's revolve it around the line x equals -2. So just to give you an idea, what does that mean? That means that there's a line right here. Let's call it x equals -2, and we're going to rotate this no longer around the y-axis, right? But now we're going to go around x equals -2. Again, the parabola is still the outer radius. So there's no shift there. This structure is still going to hold, right? That square root function right here is going to go first, the line is going to go second. What's going to change is me taking into account that line. So the only thing that really changes in my setup here we go, volume pi 3, 7.5, right, is I got to go square root y minus 3 over 2 minus the line of revolution. Still got to square it. Same thing with the inner radius, right? So y minus 3 over 3 minus negative 2, square that, call it a day. That's it, right? So now if you're catching on, right, you'll know that we're going to just do another switch up here real quick. Now we're going to rotate it around x equals 4. Well, a little bit of a change here, right? Because now, let's just redraw this real quick. Parabola, line, right? If x equals 4 is out here, what changes? It's the outer versus the inner radius, right? Now the line is further away from that axis than the parabola. So the big change here, right, all this is still the same, but the big change now is that the order of those functions is going to change. Of course, that line is going to be different too, but that's really the big switch. So now we're going to have y minus 3 over 3 minus 4, right? That'll go first because the line is the outer radius. Then we'll take away the square root function. Whoops. There you go. Okay, so hopefully those different scenarios have been helpful. As always, right, pause the video, rewatch it, slow it down a little bit maybe. But that's really what you can expect to encounter from really any type of washer problem with a vertical axis of revolution. Hope that helps. Good luck.